Historically, the standard calendar invite has functioned as a dead end. Built on the ICS protocol, these invites are essentially static, one-way file drops. Once that file downloads from a host server and lands on a local device, the connection is severed. You cannot track if the user opened it, and you cannot push live updates to the file after the fact. But look at this interface. Here, a user simply asks CRUD for a list of August games at Fenway Park. The AI parses the request, retrieves the schedule, and dynamically generates a live calendar invite, dropping it straight into their inbox. What makes this seamless interaction possible is the underlying architecture doing the heavy lifting, the Calendar Invite Server, or CIS. CIS takes that static, isolated ICS file and converts it into a dynamic, stateful object that can be queried and manipulated via REST APIs. By leveraging an AWS serverless architecture, CIS essentially turns standard email and calendar clients into a headless content management system. Because the calendar object maintains its connection to the server, you can push real-time payload updates and pull bidirectional RSVP telemetry at scale, entirely bypassing the need for custom web dashboards. To understand exactly how this works, we are going to reverse engineer the pipeline using a massive data payload, a full 2,400-game Major League Baseball schedule. Mapping this pipeline requires tracking our dynamic event payload across 4 distinct phases. First, the initial data ingest. Second, the outbound distribution. Third, real-time state mutation. And finally, bidirectional telemetry. We begin with the inbound processor pipeline, which handles the initial data extraction and load. This system utilizes a zero-training ingest methodology. The event organizer bypasses proprietary database forms entirely, using the native Google or Outlook calendar clients they already know. Inside a calendar UI, the organizer creates the event and adds our system address, create@calendarsnack.com, to the guest list. Sending this routes the schedule data straight to an AWS simple email service mailbox. This incoming payload immediately wakes up an AWS Lambda inbound processor, executing the automated ETL sequence. First, the Lambda function validates the request by checking the sender's email address against a master list of authorized users. Once authorized, the function parses the event parameters out of the email and commits them directly to an AWS DynamoDB table. To close the loop, AWS Simple Notification Service fires an email back to the organizer, confirming the event payload is staged and ready for distribution. This serverless ETL pipeline completely removes database generation from the web browser. The native calendar client acts as a purely headless ingestion node. With the payload secured in DynamoDB, the architecture shifts focus to the outbound processor to handle data requests. Distribution is triggered by an external consumer interacting with a web interface, an email template, or an NLP prompt. On this MLB fan site, a user inputs their email address and clicks Send Invite to request a specific game payload. That click executes a REST API call straight to the CIS outbound processor. The outbound processor queries DynamoDB for that exact event's metadata and generates a client-side invite file. During generation, the system executes its most critical engineering step. It embeds a unique API UID directly into the code of the ICS payload. This API UID serves as a persistent tracking token. It permanently tethers the decentralized client calendar back to the central DynamoDB record. Delivered via AWS SES, the generated invite arrives and renders in the user's inbox as a native, recognizable calendar event. Through the insertion of that API UID, a standard one-way file drop becomes a permanent, stateful connection between the server and the local device. This persistent connection solves the complex problem of state mutation. If you need to add a last-minute promotion to a game, you have to push that update to an event that is already sitting on thousands of individual client devices. Following the headless rules of the architecture, the organizer does not log into an external dashboard to make this change. They simply open the original event on their local calendar client and edit the text natively. Here, the organizer creates a data delta by typing in a new promotional offer for a gym biker dog and hitting save. Saving the event re-pings the create@calendarsnack.com guest address, instantly re-engaging the SES inbound processor. The Lambda function recognizes the incoming data as an update to an existing event. It isolates the text delta and registers the change against the original API UID inside DynamoDB. This database mutation automatically triggers the outbound processor. The system queries DynamoDB for every consumer email address tied to that specific API UID and dispatches the updated payload en masse. On the client side, the local calendar recognizes the token and seamlessly replaces the old description with the new promotional copy. The end user does not have to refresh a website, update an app, or manually re-download a file to see the change. By linking the native syncing protocols of standard calendar clients with the embedded API UID, CIS manages complete state synchronization across a massively decentralized network. Which brings us to the final phase of the payload lifecycle, capturing user engagement telemetry. When a user clicks yes, no, or maybe inside their local calendar, the embedded API UID routes that response back to the CIS API gateway. DynamoDB catches these incoming status updates and maps them strictly on a per-customer and per-event basis. This table shows the depth of that telemetry. Individual email addresses are logged alongside their precise RSVP status and the specific origin point where they originally requested the invite. Organizers can trigger the API to compile and email this data directly to them, providing a clean, PII-compliant roster for targeted downstream marketing. Through the API gateway, an isolated click inside a private local calendar is converted into a structured, server-side data metric. Ultimately, this aggregated DynamoDB telemetry is pulled by dedicated display APIs to render macro visual analytics, like this reporting hub showing over 300,000 total invites sent across the domain. This system report dashboard visualizes the aggregate throughput further, mapping out exact RSVP response ratios and the categorical distribution of invite sources. The entire architecture replaces manual database management with an automated, continuous data loop. It completely decouples the database from proprietary user interfaces, relying exclusively on standard email protocols and REST APIs to move information. Relying on these low-friction, ubiquitous protocols allows the system to handle massive scale without corresponding increases in user training or front-end maintenance. This frictionless back-end flexibility is exactly why this architecture is perfectly suited for integration with modern AI wrappers. By treating the calendar event as a stateful, API-addressable object rather than a static file, architectures like CIS allow natural language models to natively ingest, distribute, and track complex logistical data.